Hi everyone, this is lecture 04 on structural dynamics. This is continuation of lecture 3, that is Duhambel's integral. So in the previous lecture we have seen how to derive response for a dynamic system subjected to constant force, then rectangular load and triangular load. So in this lecture we are going to see the response of a system subjected to uh, triangular pulse load. Of course, in the last lecture, we have seen what is Duhambel's integral and how the limits are arrived. And for general dynamic loading, how the response looks like for a single degree of freedom and undamped and forced system. So undamped and single degree of freedom system. So the response x of t equal to u0 cos omega t plus v0 by omega sin omega t plus 1 by m omega 0 to t integration f of tau sin omega t minus tau into d tau. This is free vibration response. This is the response of a arbitrary load. Arbitrary load. So u0 is initial displacement. V0 is initial velocity. T is the time period. Omega is the natural frequency. So we are going to derive the response of the single degree of freedom system, that is undamped single degree of freedom system subjected to triangular pulse load. So the mass of the system is m, stiffness of the system is k, and the response is x of tau. This is your response, and this is your applied force. The applied force diagram is given here. The variation of applied force versus time is shown here. It looks like a pulse loading, and the shape resembles a triangle. So you could able to see a two right angle triangle exactly bisected at t0 by 2. The amplitude is f0. Amplitude is f0. So this is an undamped oscillator acted upon a triangular pulse load. So how to derive the response? So equation of a line for a time period uh, t less than t0 by 2. So here t less than t0 by 2. Then another section is here. T is in between t0 by 2 to t0, and another point t is greater than t0. So these are the three phases. This is phase 1, and this is phase 1, and this is phase 2, and this one is phase 3. So we have to derive the response for these three phases. So for the phase 1, when t is less than t0 by 2, your forcing diagram, that is your force that equation of this forcing diagram is resembles y equal to mx plus c. Here y is the force, x is the tau. Tau is nothing but time period. So m is nothing but slope and c is nothing but intercept. So this is your interested line. This is your line, and here you can see the vertical height. The vertical height is f0 and the horizontal distance is t0 by 2 actually. So this is your horizontal distance. So your slope is nothing but opposite side by adjacent side. Uh, uh, so opposite side is f0 and adjacent side is t0 by 2. So the vertical portion is f0 and the horizontal portion is t0 by 2, and intercept is 0 because the line starts from here. So therefore c equal to 0 actually. So f of tau equal to 2 f0 divided by t0 into tau. So that is nothing but 2 f0 tau divided by t0. The response of a single degree of freedom subjected to undamped forced vibration. So, which I explained here earlier. So your response is for a Duhambel's integral for any arbitrary load, the equation, the response of a single degree of freedom undamped system is x of t equal to u0 cos omega t plus v0 by omega sin omega t plus 1 by m omega 0 to t f of tau sin omega t minus tau into d tau. Here the initial velocity equal to 0 and initial displacement equal to 0 and initial velocity equal to 0. Therefore, this whole term gets 0. Only the response is the leftover response is x of t equal to 1 by m omega 0 to t f of tau sin omega t minus tau into d tau. So here f of tau we have derived from the um, uh, uh, line equation. So the f of tau equal to 2 into f0 tau divided by t0. So just take the constant terms out. So 1 by m omega is there. So 2 f0 divided by t0 m omega. So this you are taking the constant terms out, and you have 0 to t integration tau sin omega t minus tau into d tau. So here the tau is also a variable, and here sin omega t minus tau is also a variable. So you have two tau variables. So you cannot solve by conventional method. So you have to use integral udv formula. So what is the integral udv formula is saying? The formula is integral of u into dv equal to uv minus integral of v into du. So integral of u into dv, so how it resembles? So this is the term we are rewritten here. Uh, so tau in the integral of tau into sin omega t minus tau into d tau. So the terms u derivative of u integral of dv and that is v are required to solve the integral u dv. So first you need u, derivative of u that is du, integral of dv that is equal to v. So you need these three terms to solve this integral of u dv. So what is u? U is nothing but this is your u and this is your dv. This is your dv. So u equal to 1, u equal to tau, du equal to 1, your dv equal to sin omega t minus tau. Just multiply this omega inside. You will get sin minus omega tau plus omega t. Just integrate this. You will get cos omega t minus tau divided by omega. So here I asked you to use this chart to find the derivatives and integral of sine and cos. So here you have to find the integral of sine. So integral of sine means here it is your positive sine theta. So integral means is your negative sine theta. So minus sine theta you have, minus cos theta you have, already you have minus here. So this minus minus term get cancel actually. So minus cos um, into minus omega tau plus omega t divided by minus omega. So this minus minus get cancelled. So that is why um, um, you get positive cos omega t minus tau divided by omega. So integral of u dv equal to tau cos omega t minus tau divided by omega minus cos omega integral of cos omega t minus tau into omega. So this is your formula. If this is your u into v. So you know u, you know v, and so this is your uv. Then you know du and you know the v. So v into du. So du is nothing but 1. So this is how you arrive your u dv. So so integral of tau into sine omega t minus tau into d tau is equal to tau into cos omega t minus tau divided by omega minus integral of cos omega t minus tau. That is just multiply this omega term inside and here also inside. So cos minus omega tau plus omega t divided by omega. Then subsequently you get your results like uh, uh, the tau cos omega t minus tau divided by omega is same. At the same time you are using the integral here. So integral of cos, integral of positive cos theta. So if you have, this is the integral second black color curve. So cos theta you have to find plus sine theta. So integral of uh, cos theta is plus sine theta, whereas here on minus omega is there, that minus will come out and this minus and minus get plus. So that is how here we are getting plus sine omega t minus tau divided by omega square. So by applying the limits 0 to t, then the response is f0 divided by t0 m omega tau into cos omega t minus tau divided by omega plus sin omega t minus tau divided by omega square. Just substitute the t terms here and here. You will get this t into cos omega t minus t divided by omega plus sin omega t minus t divided by omega square. Then you substitute 0 here and 0 here, you will get the second term. So this is the first limit and this is your second limit actually. So first limit is nothing but tau equal to t and the second limit is tau equal to 0. So this is tau. Both should not look same. This is tau equal to t and here tau is equal to 0 and subsequently this t get cancelled, this is get cancelled and this is become 0. So you will get t by, and this whole term is 1 actually, and here sin omega t is remains same. So you got the response as f0 divided by t0 m omega t by tau minus sin omega t divided by omega square. It is further simplified. K equal to m omega square. Omega is equal to square root of k by m. So you get just you substitute take this omega and 1 omega out. So you will get m omega square, m omega square. So is further simplified as f0 divided by t0 k t minus sine omega t divided by omega. So this is the response for a time period t less than t0 by 2. So this is your response when t is less than t0 by 2. So that means your t value is somewhere here. T is less than t0 by 2. So this is how you get your response for the phase 1. Next one is phase 2. So the next phase 2 diagram, the equation of line is further written as. So we know the time period is within this time period t0. Your time t is somewhere in between t0 by 2 and t0. So this is your response. For this line only, you have to find the response. So for step loads up to 0 to f0 and t0 by 2 to f0. So 0 to f0 also you have to find the response. What is the response? So for that, uh, the step loads 0 to f0. So your this is your 0, 0 to f0, and the horizontal line is t0 by 2 to f0. Here the dotted line is the equation of line. So here slope is positive f0 divided by t0 by 2, and intercept is 0 actually. C equal to 0. So your equation of line is f of tau equal to 2 into f0 divided by t0 into tau. So your forcing function or forcing term is 2f0 tau divided by t0. At the same time, when the time period is from t0 to 2f0, that means the line equation and t comma 0. So the somewhere the t is in between here. So your line equation is f of tau equal to mx plus c. So your for this line equation, intercept is 2f0. So this is your intercept. That is equal to 2f0, and your slope is equal to your horizontal term is f0, and the horizontal term is t0 by 2, and your vertical term is minus f0. So you get your slope as minus 2f0 divided by t0. Then the equation of line becomes f of tau is equal to 2 into f0 into 1 minus tau divided by t0. So this is your response for a time period within t0 by 2 to td or t0. So your total response is u0 cos omega t, v0 by omega sin omega t plus 1 by m omega integral 0 to t f of tau sin omega t minus tau into d tau. So here your initial velocity, initial displacement is equal to 0, initial velocity equal to 0. So your response further simplifies to 1 by m omega 0 to t f of tau sin omega t minus tau into d tau. So from the loading diagram, we understood that 0 to t directly cannot be applied. So the limit needs to be applied is 0 to t0 by 2. This is your first part, and this is your second part actually. t0 by 2 to t actually. So therefore, your up to 0 to t0, your forcing function is 2f0 into tau divided by t0, and the second part forcing function is 2f0 into 1 minus tau divided by t0. So the rest of the term is same, sin omega t minus tau into d tau, sin omega t minus tau into d tau. So only the limits needs to be carefully applied. So remaining everything is very simple. X of tau equal to 2 f0 divided by m omega. So just you have taken the 2 outside. In the both terms, 2 is constant, so you have taken the 2 outside. So this is the whole part belongs to integral 1, and this part belongs to integral 2. So just for namesake, just to give a better understanding, I'm naming it as integral 1 and integral 2. So the integral 1 is from 0 to t0 by 2 tau divided by t0 sine omega t minus tau, and the integral 2 is tau 0 t0 by 2 to t integral 1 minus tau divided by t0 sine omega t minus tau into d tau. So here the part I want to say here is, so here also you have two variables. This is one variable and another one is tau. So you cannot use the conventional method. You have to use integral udv method formula for solving this equation. So here also you have tau and here also you have tau. So you cannot solve by your conventional simple equations. You cannot apply. So you have to use your udv formula. So integral 1, tau equal to 0, tau equal to t0 by 2. So this is your limits 0 to t0 by 2, tau into sine omega t minus tau into d tau. So your udv formula you have to apply. So of course you need u and its derivative du. Already we have derivative dv. In the integral of dv we want. So we need u and dv, and we need to solve this equation. So u equal to tau, du equal to 1, then dv equal to sine omega t minus tau. So integral of sine is cos and minus cos. So already here one minus will be there, so minus minus get plus, and you get v equal to cos omega t minus tau divided by omega. Just substitute this v, so just substitute this all this thing in this udv formula. You get tau cos omega t minus tau divided by omega minus integral cos omega t minus tau divided by omega. So again, just you have to integrate. You have to integrate this uh, uh, second term, that is cos, integration of cos minus omega tau plus omega t divided by omega. So if you want to differentiate, integrate the cos. So this is your cos, and you have to integrate. You have to use the second circle. So second circle is showing that plus sine theta. So integral of plus cos theta is plus sine theta. So here one minus is there. So minus omega is there. So therefore this minus and this minus and this minus get cancelled. You will get plus sine omega t minus tau divided by omega square divided by omega. So that means here already one omega is there. So we are getting omega square. So integral of u dv. So this is your term, integral 1. This is your integral 1. So u dv equal to 1 by t0 tau cos omega t minus tau divided by omega plus sine omega t minus tau divided by omega square, integral limits 0 to t0 by 2. So first you have to apply this t0 by 2 limit to this portion, and this tau and this tau, and next you have to apply your 0 limits to here and here. So this is what applied here. So 1 by t0 is same, and just you have applied the limit t0 by 2 cos omega t minus t0 by 2 divided by omega plus sine omega t minus t0 by 2 divided by omega square divided by 0 cos omega t divided by omega plus sine omega t minus 0 divided by omega square. Of course, we multiplied, so this terms get 0, and here you will get t0 by 2, and here also you will get t0 by 2. Only one term get cancelled. So only one term get cancelled. So out of four, only one term get cancelled. So you have three terms actually. So you are familiar that 1 by t0 is multiplied inside at all the levels. So this is multiplied with the three terms here and here and here. So this is at three locations. It is multiplied inside just to keep omega square and omega square. Just to keep this, we have multiplied that inside. So this t0 and t0 get cancelled. So you will get 1 by 2 cos omega t minus t0 by 2 divided by omega plus 1 by t0 sin omega t minus t0 by 2 sin 1 by t0 sin omega t divided by omega square. So now this is your solution for integral 1 actually. Now solution for integral 2. So integral 2, your tau limits are 0 to t0 by 2 to t actually. So kindly note this point. The integral limits is up to t actually. So you know the UdV formula. This whole term is your u now, and this term is your dv now. Okay, so your u equal to 1 minus tau divided by t0 and du equal to minus 1 by t0. So when you differentiate this term, you will get 1 will get 0 and the remaining term is minus 1 by t0. So of course I told about this derivative of dv is cos omega t minus tau divided by omega. So just substitute this u value, du and v in the equation, that is u dv equal to uv minus integral v du. So u into v. So v is this term and this is your u term and this is your v term, and integral v into du. So v is this term and your du is this term. Now you have to differentiate this whole term one time with respect to tau. So if you differentiate this 1 by t0 is a constant. So this minus and this minus get plus, and integral of cos omega t minus tau divided by omega. So the remaining term is uv is remains same. There is no change. So udv equal to 1 minus tau divided by t0 cos omega t minus tau divided by omega minus 1 by t0 sin omega t minus tau divided by omega square. Just uh, uh, apply the limits. So now it's time to apply the limits here. So your limits are t0 by 2 to t. So you have to apply these limits. So your t term needs to be applied at the point here and here, and then your t0 by 2 needs to be applied at the tau locations. So your first term, when you apply this t, you will get 1 minus t. So here also you have 1 tau. So this needs to be applied to here also. So 1 minus t by t0 cos omega t minus t divided by omega minus 1 by t0 sin omega t minus t divided by omega square minus this is your upper limit. Then next your lower limit. So 1 minus t0 by 2 divided by t0 cos omega t minus t0 by 2 divided by omega minus 1 by t0 sin omega t minus t0 by 2 divided by omega square. So this is further simplified as so this whole term is equal to 1. So your first term looks like 1 minus t divided by t0 divided by omega minus 1 minus t0 divided by 2 divided by t0 into cos omega t minus t0 by 2 divided by omega. So just you brought these omega terms together. Next, omega square. This is your omega square. So here this t minus t is equal to 0. So this whole term gets 0. So you will have the leftover term is only this one. You have minus minus get plus. Um, and here you will get positive 1 by t0 sine omega t minus t0 by 2 divided by omega square. Just to rearrange omega, omega, omega square, we have rearranged it. So 1 minus t by t0 divided by omega minus 1 by 2 cos omega t minus t0 by 2 divided by omega plus 1 by t0 sine omega t minus t0 by 2 divided by omega square. So this is your response for the time period t0 by 2 to t0. So now you have to add this integral 1 and integral 2 actually. Um, uh, Actually, previously I told that that is the response. Actually, that is a part of the response. So now, after adding this integral 1 and integral 2, you will get the total response. So just by adding this integral 1 and 2, you get a very lengthy expression. You get 1 minus means response is equal to 2 f0 divided by m omega. You have 1 minus t by t0 by omega minus 1 by 2 cos omega t minus t0 by 2 divided by omega plus 1 by t0 by sine omega t minus t0 by 2 omega square plus, so this is one part and this is another part actually. Uh, 1 by 2 cos omega t minus t0 by 2 divided by omega plus 1 by t0 sine omega t minus t0 by 2 minus 1 by t0 sine omega uh, t. So just subtract the terms and it will be further simplified to 1 minus t0 by t by t0 divided by omega. So this cos term gets cancelled. So this term and this term get cancelled. You will get only uh, sine 1 by t0 sine omega t divided by omega square, and this you will get this one and this one will be added together, and you will get 2 divided by t0 sine omega t minus t0 by 2. So this is further simplified as you take 1 omega from each term here, you will get outside. So you will get this m omega square. So k equal to m omega square and omega equal to square root of k by m. So your response is further simplified as x of t equal to 2f0 by k 1 minus t by t0 plus uh, 1 divided by omega into t0 into sine 2 sine omega t minus t0 by 2 minus sine omega t. So this is your response for a time period t0 by 2 to t. T0 by 2 to t0. So now the response for a time period t0 greater than t. This is your t0. T is greater than t0. So this for that you have to find the response of these two lines is required. The equation of the line t0 less than t. So for 0 to f of tau equal to mx plus c. So this term, this equation and this line needs to be written here. So intercept c equal to 0. So for the first line, intercept t equal to, this is your first line, this is your second line, this is your second line. So f of tau equal to 2 into f0 divided by uh, t0 into tau. So your step loads are T0, comma 2 F0 and T, comma 0. So these are the points actually. T, comma 0 and T0, 2 F0. So your intercept C equal to uh, uh, 2 F0 actually. So your response is slope is equal to minus 2 f0 divided by t0. So your equation of the line is f of tau equal to minus 2 uh, f0 divided by t0 into tau plus 2 f0. So your equation of the line is further simplified as 2 f0 into 1 minus tau divided by t0. So for a time period t0 by 2 uh, between tau is been between t0 by 2 and tau 0. So your response is u0 cos omega t plus v0 by omega sin omega t plus 1 by m omega integral 0 to t f of tau sin omega t minus tau into d tau. Here initial displacement equal to 0, initial velocity equal to 0. So your response is further simplified to 1 by m omega 0 to t f of tau sin omega t minus tau into d tau. But f of tau cannot be directly applied. So you have two terms are there. So your um, uh, you have to apply 0 to t0 by 2 and t0 by 2 to t0 needs to be evaluated. So your equations forcing functions are 2f0 tau divided by t0 and 2f0 1 minus tau divided by t0. So remaining the sine term is same and here also sine term is same. So this part is named as integral 1 and this part is named as integral 2 actually. So just for uh, simplification purpose, uh, your integral 1 limits are from 0 to t0 by 2. So you have to use this udv formula. So your uh, you should know u, v and du. So you know that u equal to tau and du equal to 1 and v equal to cos omega t minus tau divided by omega. So this is a derivative. So here you know this is your sin theta and your derivative is plus cos theta. Since you have uh, minus here, sorry, your it is your integral actually, not derivative, it is your integral. So integral it is minus cos theta. So your minus term and the another minus term get cancel and become positive. So your V value is cos omega t minus tau into d tau. So your UDV formula is rewritten as U into V. So V is nothing but cos omega t minus tau divided by omega, then V into du. So d is nothing but 1. So this is nothing but 1 and integral of V du. So just differentiate this cost term, you will get uh, just integrate this cost term. So if you integrate the cost term, you will get minus sin theta. Already you have another minus, so minus minus get cancelled. That is why you are getting plus sin omega t minus tau divided by omega square. So your uv is nothing but tau into cos omega t minus tau into t minus tau divided by omega actually. So your total response is 1 by T0 uh, tau cos omega t minus tau divided by omega plus sin omega t minus tau divided by omega square integral 0 to T0 by 2. So this limits needs to be applied at these two levels, and this limits also needs to be applied at these two levels. So you get this is your upper limit and this is your lower limit. So when you apply this T0 by 2, T0 by 2, then 0 is up, 0 is turned here. So you have 0, this whole term gets 0, and sin omega t you have. So just rewriting this, you will get in terms of denominator omega square. So you will get um, 1 by T0 multiplied inside at all the places, at all the over the three terms. So this T0 get cancelled. So you get the term 1 by 2 cos omega t minus T0 by 2 divided by omega plus 1 by T0 sin omega t minus T0 by 2 divided by omega square minus 1 by T0 sin omega t divided by omega square. So next to the integral 2, so integral 2 limits from tau 0 by 2 to t0 divided by 2 to t0. So your first integral part is, that is means u is equal to 1 minus tau divided by t0. So your d equal to 1, d equal to minus 1 by t0 because tau is the variable. So your dv is as I explained earlier. So this is your sine. So you have to find the integral. This is your sine theta, and you have to find the integral. Integral is minus cos theta. So already you have minus omega. So you this minus minus get cancelled. Your v value equal to cos omega t minus tau divided by omega. So your UdV is written like this. So this is your U and this is your V. UV minus integral of V into du. So this du is nothing but 1 minus t0. So that is a constant. You can take it outside. Remaining term needs to be integrated. So 1 minus tau by t0 cos omega t minus tau divided by omega into this integral. Just integrate the cos term. So you will get sine term, sine omega t minus tau divided by omega square. That is minus. So now we are applying the limit on the integral 2. So this whole term is integral 2. So we are applying the limit t0 and t0 by 2. So you will get 4 terms actually. So 1 minus t0 by t0 cos omega t minus t0 divided by omega minus 1 by t0 omega t minus t0. So next term is 1 minus t0 by 2 divided by t0. So cos omega t minus t0 by 2 divided by omega minus 1 by t0 sin omega t minus t0 by 2 divided by omega square. So your previous term get cancelled, and it is further simplified as uh, minus 1 by t0 sin omega t minus t0 divided by omega square minus 1 minus t0 by 2 divided by t0 cos omega t0 minus t0 by 2 divided by omega 1 by t0 sin omega t0 minus t0 by 2 divided by omega square. So it is further simplified as in a simple form. If you write minus 1 by t0 sin omega t minus t0 divided by omega square minus 1 by 2. So this term and this term get cancelled. So you get 1 by 2 cos omega t minus t0 minus t0 by 2 divided by omega plus sine 1 by t0 sin omega t0 minus t0 by 2 divided by omega square. So just you have to add this integral 1 and 2. So you are getting such a long term. So the last three terms belongs to uh, so this three terms belongs to the integral 2. So this three terms belongs to the integral 2, and other terms belongs to integral 1. So x of t equal to, further simplified as x of t equal to 2 f0 divided by m omega 1 by t0 2 into sine omega t minus t0 by 2 divided by omega square. So this is your omega square and this is your omega square. Then minus 1 by t0 sine omega t divided by omega square. So this is your this term, and 1 by t0 sine omega t minus t0 divided by omega square. So this is your this term, and your uh, cos term get cancelled, and this term is, you have to add these two terms. So you are getting 2 here. So you get 1 x of t equal to 2 f0 divided by m omega. So just you take this omega square, whole omega square out here. So you will get 2 f0 divided by m omega cube into 1 by t0, 2 into sine omega t minus t0 by 2 minus 1 by t0 sine omega t plus 1 by t0 sine omega t minus t0. So you know m omega square equal to k equal to m omega square. So so it is further simplified as, so all the t0 is taken outside. So this all the t0 is taken outside. So you got the response as uh, so this is your response for time period t to t0 by 2. So t less than, if your line is here, t is less than t0 by 2, and if your line is this here, t0 by 2 to t less than t0, and if it is here t0 is greater than or equal to t. So for these three responses, you got the limits from 0 to t, and second one limits 0 to t0 by 2 to, and the t0 by 2 to t, and our limits are from 0 to t0 by 2 and t0 by 2 to t0 actually. So this is how your response here. So the response is further divided and simplified, and we got the final expression as here. X of t equal to f0 by t0 by k, f0 by t0 k into t minus sine omega t divided by omega, and your second response is 2 into f0 by, divided by k into 1 minus t by t0 plus 1 by omega t0 into 2 sine omega t minus t0 by 2 minus sine omega t, and the response t0 less than or equal to t, then the response is 2f0 divided by t0k into 2 into sine omega t minus t0 by 2 minus sine omega t minus sine omega t minus t0. This is your response for a triangular pulse load. So your reference books Professor Anil K. Chopra's Dynamics of Structures, uh, Structural Dynamics by Professor Mario Pos, then NPTEL lectures by Professor Ria Catherine George from Hiroshima University, Japan, uh, uh, Professor Meera Mitra from IIC Bangalore, from Aerospace Engineering Department, and their video lectures I have referred. Of course, many of the NPTEL lectures are very, very helpful for preparing this video. Then Professor Srinivasan Chandrasekhan from Department of Ocean Engineering, Indian Institute of Technology, Madras. Sham series book, that is the mechanical vibrations, that is also useful for solving the problems. Professor Sudip Talukdas NPTEL lecture, Professor Pradipta Banerjee's NPTEL lecture, and lastly Professor Pradeep Kumar's Ramchalla's NPTEL lectures. So these are all good video lectures I have referred, and also the books I referred. And with this I conclude my session here. The next lecture will be on the for finding the response of half sinusoidal pulse load. Thank you.